inside, imagine you are inside a lift. You press the button 112, you want to go to the 112th floor. Okay, you just get inside the lift, you press the button, the lift is taking you up. But there is initially an acceleration, right? Because the lift was already at rest. Correct. Now it is speeding up. Maybe for the first couple of floors. Or will it keep speeding up forever? No. Maybe like third, fourth floor. Until third or fourth floor, the lift will accelerate. Then the lift will keep moving at same speed, right? In the end, say 108th floor, till 108th floor. Then it will slow down a bit. Eventually, it will come to rest. So the motion of a lift is in fact a combination of accelerations, uniform motions, and decelerations, just like your car. When your dad takes your car from home, initially there is an acceleration, right? Because he has to start it from rest and he has to hit a particular speed. Correct? But once you enter an express highway, you maintain the speed. You put the car in the cruise mode, right? That is called uniform motion. And eventually, suddenly when someone comes in front of you, you apply brake. That is deceleration, right? So almost all motions around you, like that of a car or that of a lift, are combinations of what? Accelerations, uniform motions, and decelerations, retardations. Understood? So look at this situation. The lift is accelerating up. All right, accelerating up. See this? This is you. The weight is acting down. Normal reaction is acting up. Imagine the lift is accelerating up. You are on the ground floor. You get inside the lift. You press the button. The lift is moving up. Okay. So tell me the scenario. Tell me what's going to happen now. I'm going to write an equation. Which force is bigger now? Which force is bigger now? It's going up, right? Going up means upward force is bigger. What did we see here? It was going to the right. So rightward force was bigger. Here, it was going down. So the downward force was bigger. So the force, which force is considered bigger? The one in the direction of motion. Okay, the one in the direction of motion. Do you hear me? Right. So it's going up means R must be greater. So I could say that R minus mg, upward force minus downward force, should be equal to what? Ma. Right? M into A. So that is what? R is equal to mg plus ma. Or it is m into g plus a. So look at the normal reaction. It's in fact, I was expecting it to be mg, which is the normal case, but it has become m into g plus a. So what does it mean? This is called apparent weight. The weight you're feeling, it is greater than the actual weight. Actual weight is mg only. Understood? So I can say that the apparent weight, listen to me please, apparent weight, this is the weight you are feeling inside an accelerating system. It is greater than the actual weight. All right. And it happens inside the cockpit of a fighter plane. You know, they feel like 7G, 8G. It's called G factor. 7G means you're feeling 7 times your actual weight. I've told you once in class. Okay, fighter pilots, when they do the vertical climbing, they feel this. Or even during launching of space shuttle, astronauts feel this. Space scientists, no? They have this G factor on their body. 6G, 7G, up to 8G. Or F1 car racing, car drivers, no? They have this like 3G, 4G on their body. It's very difficult to maneuver a car at this high G values. Understood? And even the fighter pilots, no? When they're certain that a plane is about to crash, they'll simply let the plane go. They'll take the plane to some uninhabited places. They'll let the plane crash. But before they do that, they'll pull a lever, seat ejection mechanism. And during the lift off, during the what you call this lever lifting, you know, they'll feel like, say, maybe like 10G for 15G. And once I read, one pilot was feeling 19 times G. That means if his actual weight was like 100 kg, he was feeling like 1900 kg on his body. Understood? He had like permanent decrease of height. The spinal cord got contracted by few millimeters. All right. Spinal cord. All right. And even later on, you saw this in a video. Later on, Later on, one scientist actually, he was actually designing seat belts, and he did a car crash. The car was brought to rest from 700 km per hour to 0 in 1.5 seconds. Okay, that was such a deceleration that he had like 40 G on his body. You saw this in a video. His ribs got broken, eyeballs popped out. He eventually survived the crash. But still, that is one of the greatest ever G survived. All right, 40 G. Nobody ever thought that such a G factor could be survived. All right, it is like throwing you onto this wall at a speed of 200 km per hour. So imagine yourself being thrown onto this wall, concrete wall at a speed of 200 km per hour. Okay, you'll be shattered into pieces. But still, he survived the crash. All right. And then this car crash, which actually happened like 10 years back, I think. I'm not sure about it. You might have seen that. Now, this is the largest ever G factor. Oh, that's not largest ever G factor. Largest ever G factor recorded. That was a phenomenal 214 G. Hope you remember this. Even then, he survived the crash. Okay. That was like 214 G, which means at that time of crash, he was feeling like 214 G, which is like 214 times his weight. Even then, surprisingly, he survived the crash.
Car heavily damaged, but we have one other car right now that is very, very heavily damaged.
Now, what will the IRL do? What will the officials decide to do? The debris from Kenny Breck's car down way up into the fence. Almost reminds
Here is the crash again.
Kenny Breck and try to stabilize it. Air is the replay of what happened. Breck on the high side of Thomas Shepherd down the back stretch. At the end of the back stretch, there's the Here's the shot now from the
Even and this is the test I was talking about. This is the G factor. The 40G thing, no? Car was being driven with, that is with a rocket engine. It's in fact a rocket engine. Right. It was fired by a rocket engine. And they are going to test one in Nevada this time. This car is going to be driven at 1,600 km per hour. 1,600 km per hour in November or December in US. He used 48 braking systems to bring it to rest in less than 1.5 seconds. Imagine stopping a car moving at 700 km per hour. Right.
He experienced a phenomenal force of 40 Gs, more than anything scientists thought humans could survive.
But I'll show you something. There are like even greater G forces. Greater G forces, I'll tell you. Different G value. Standing on Titan is 0.138. Just see this. There is a comparison. 2.53 standing on Jupiter and average sneeze. Tower Terror roller coaster somewhere in South Africa. Right. Tower Terror. It's a roller coaster. It's like 6.3 G. You can experience 6.3 G. Then see this. 50 G. Human serious injury. Right. Human death 100 G force. Instantaneous death. Yeah. Sun coronal mass ejection. V8 Formula 1 engine. Piston force. 8,000 G. Right. So it's like 10,500 G force, military artillery shells, electronic, right? The washing machine, centrifuge, 300 kg force inside the washing machine. You won't survive in a washing machine, right? Maybe, right. So that is supposed to be the largest G factor, 2 into 10 raised to 11 G force standing at the surface of a neutron star. Neutron star is so powerful. Okay, right.